Hello, and thank you for joining this RedShield presentation and shielding service demonstration. So the first and most obvious question is, why RedShield? Today's business world is built on and relies on applications. According to the Gartner Group, U.S. companies spent nearly $150 billion on enterprise software applications in 2015. During that same time, just under $600 million were spent globally on security testing products. That's over 250 times more on the applications than the security for those applications. And, according to the 2016 White Hat Security Report on application security, every business web application has vulnerabilities, and less than 5% of all applications have an exceptional application security profile. Across all industries, the average time to fix for vulnerabilities is 100 to 245 days, with critical and high-risk vulnerabilities staying open for 300 to 500 days, leaving both businesses and users with significant exposure. Using code remediation alone to fix application issues is a problem, and it's getting worse. Every year, fewer vulnerabilities are being closed out, and the software industry is just falling further behind. With new and updated software frameworks, new and different kinds of software, pressure to release new features, and speed to market, IT teams are creating security flaws at an alarming rate. Clearly, the long-standing approach of using code remediation alone to close vulnerabilities is failing businesses of all industries. Today's approach is just an infinite loop with no relief. New vulnerabilities are constantly being discovered and added to the remediation stack that we already know isn't keeping pace. There has to be a better way. What are we left with? Using tools such as WAFs only address half of the problem. What about business logic flaws in applications? Some organizations just risk accept and hope for the best. Others are trying to fix the code if they have access to it, and still others are forced to function disable, causing loss of critical business functions. So why RedShield? Because there is a better way. Shield first, then remediate. RedShield is the world's first shielding with a service company, and we have turned web application security into a process instead of a product. We use a combination of industry-leading tools along with custom microservice code objects that we call shields, run with inline proxies and mature security process, all operated by security experts to protect your web applications. We aren't selling an appliance or another security tool, just an outcome. It's called secure. Founded, owned, and operated by security industry experts, we have a growing shield library of over 30,000 shields, which means we have probably seen your issue or some variant of your issue already. Our ever-expanding shield library is constantly being updated to handle new and more advanced exploit techniques, and this knowledge is shared via the shield library to benefit all RedShield customers. With RedShield in place, you can extend the life of applications with known security flaws, meet in-service deadlines and audit requirements, as well as defer patching and platform-related upgrades until they're in line with your business priorities. You also benefit from best practice vulnerability management, 24/7 support, and detailed reporting, so you know exactly what's happening with and to your application at all times. So code remediation is one problem. The other problem, to put it simply, is the bad guys are organized and the good guys are not. Comparatively, enterprise security teams are working in isolation, whereas bad actors are highly organized and often working together to achieve their common goals of evading security, stealing data, and knocking applications offline. Security operations in today's landscape is no trivial task. It's no surprise that nearly 90% of all security operations centers don't meet even minimum process maturity requirements. Even hiring experts doesn't fix the problem, as it takes 5 years or more for organizations to reach process maturity. Can your security afford 5 years of learning and process development? Probably not. Security operations isn't a simple business. With tight security controls deployments, blocking legitimate traffic and business disruption are just the norm. The industry-accepted rate for false positives is 0.02%, or 2 views in 1,000. And even with those tight controls, penetration testers successfully evade them 95+% of the time. Data analytics with SIEM and reporting tools fail to deliver meaningful, business-impacting analysis. Usually, there's just too much noise or too much data, or both. At RedShield, our Security Operations Center consistently maintains false positive rates of 0.0002%, or 2 views in 1 million. That's 1,000 times lower than the industry-accepted standard for tools alone. On top of that, thanks to mature process and industry expertise, we maintain an average time to resolution for false positives of less than 15 minutes. Talk about solving the problem of business disruption. Today it really is you against them. Businesses are no longer fighting a single enemy, rather organized, motivated criminal gangs dedicated to breaching defenses. RedShield is an organized security defense team with tools, systems, processes, and expertise to meet today's threats head on. Why not let RedShield focus on security so you can focus on your business? How does RedShield work and how are we organized? We start with a penetration test and your known vulnerabilities. We ingest this information using our proprietary data engines, verify the findings, and document and organize the results. Simultaneously, we deploy our systems to match your architecture, putting in place our tools and base security policies. Next, an advanced shielding plan is developed and combined with the base policy and tools deployment. Once testing and tuning have been completed, application traffic is rerouted to the RedShield service, typically via DNS updates. After these base protections are in place, any additional advanced shields are developed, tested, and deployed to the system. From here, our ongoing monitoring, testing, scanning, and reporting processes are used to continually validate the shielding service, making sure that your application is always fully protected. With data center locations across the globe and redundancy at every turn, RedShield is ready and available wherever you are, and private nodes located inside your data center are also available. Now let's look at a demonstration of the RedShield service in action. The RedShield service process begins with a set of known issues or a penetration test provided by the customer detailing known vulnerabilities that require shielding. To demonstrate the service, we have built a vulnerable web application and performed a penetration test to identify the vulnerabilities of the application. The application itself is a standard ASP.NET based application hosted in the cloud using Amazon Web Services. For the purpose of this demonstration, we have two URLs, one with direct access to the application without any shielding services, and a second URL that's routed through the shielding service. The direct access URL is HTTP or HTTPS www.0-days.net, and the shielded URL is HTTP or HTTPS redshield.0-days.net. It's important to note that this split URL scenario is only for demonstration purposes so that we can show vulnerabilities with and without shielding in place easily. In a production scenario, split URLs are not required. Also, the application server is the same server for both the shielded and the unshielded URLs. No server-side code is modified for this demonstration. The application is just simply a basic e-commerce site that sells various exploits for use on the internet. It has a user registration service and login, a products page, a shopping cart, a 4-step checkout order process, an order history page, and finally a couple of static information pages, about and contact. As mentioned previously, the RedShield service starts with known issues, typically in the form of a penetration test. For this demo, we have a penetration test performed by Acme Security LLC, a fictitious penetration testing company that details the vulnerabilities of the unshielded site. Per the penetration test results seen here, the site has 17 vulnerabilities ranging in severity from low to critical. For the purpose of this demo, we will focus on 4 of the vulnerabilities from the list. Those are SQL Injection, weak passwords, and 2 forms of functionality abuse against the business logic of the application. Of those vulnerabilities listed, these specific vulnerabilities were chosen because they illustrate dangerous technical flaws and stateless attacks like SQL injection that, admittedly, can be resolved using industry tools such as WAFs, as well as application and business logic vulnerabilities like weak passwords and direct object reference vulnerabilities that cannot be mitigated with other industry tools and thus require our advanced shielding objects to resolve without application code remediation. Before we dive into the first vulnerability demo, there is one more important piece of the RedShield service that I'd like to share, and that is the RedShield Client Portal. The Client Portal is a place where our customers interface with our processes and our experts. It's also the place where customers can view reports and track any issues. During the onboarding process, customer penetration tests, along with any other known issues, are ingested and correlated using a proprietary RedShield intelligence engine that we call RedBrain. RedBrain ingests penetration test findings and other vulnerabilities and correlates them to our shield library, thus helping us to build a shielding plan specific to a customer's needs. All of this, plus our management and validation tools findings, are available to our customers to view inside the portal in real time. Inside the portal belonging to this 0-days demo, we can see in the vulnerabilities section that there are no unresolved vulnerabilities. On the Shielded tab, we can see a list of all the vulnerabilities and drill down into the details, as well as the history of each finding. By clicking into the vulnerabilities, we can see evidence of the findings, solutions, and comments for each vulnerability. Okay, let's move on to the demonstration of the first vulnerability on our list for today's demo, SQL Injection. The search on the main products page is vulnerable to SQL injection attacks. If we paste a basic SQL injection attack into the search field and execute the search, we can see that it returns the entire product database. Not ideal for sure. If we move to the shielded site and perform the same search, we are immediately blocked and the user is presented with a support page. If this were a false positive, the blocking page provides the user with support contact information and the all-important support ID to allow our service desk to quickly verify, validate, and resolve this issue. It's worth noting at this point that the shielded site displays the RedShield logo instead of the 0-days logo to easily make the distinction between the shielded and the unshielded sites. Now, as I mentioned earlier, no server-side code was modified for this demonstration. So to do this logo change, we created a custom shielding object and rewrite the server response on its way to the client inline. This is a powerful capability that we will leverage in the next demonstration around weak passwords. Let's have a look at how we can use the shielding object's capabilities to resolve the server's very weak password facility. The only password requirement the application has is that it requires 4 characters. Not very secure for sure. If we go to the registration page to register a new user with a password of 123, we can see that the application requires 4 characters. Now, let's redo the registration and set the password to the word password, the world's worst password, yet sadly, as we know, one of the most common. We can see that the site allows this, and we are now logged in as user1 at redshield.co on the unshielded site. Now, we log out of the unshielded site and switch over to the shielded site and attempt the same login. Again, we can see that we are on the shielded site by the changed logo and URL. Attempting to log in as user1 with the weak password of password, the shielded site interrupts our login and redirects us to the change password page. Recall that this is protected using a shielding object that is controlling and modifying the server's built-in change password facility. If we attempt to use another weak password, such as password and the number 1, which the server on the unshielded site would have accepted, the shielded site again denies it, requesting a better password. This shielding object can be modified with any list of weak or unacceptable passwords, as well as any level of complexity checking the customer requires, all without ever updating the application code on the server. At this point, no user would be allowed to log in with a weak or common password. Pretty powerful stuff here, being able to use the existing password change facility and augmenting it in line to enforce security standards. Let's select a better password and move on. Now we can see that the stronger password has been accepted and the user is allowed to log into the shielded site. Let's log out of the shielded site and go back to the unshielded site. We will walk through the order process and place an order for user 1. First, we log in as the user. Add some exploits to our cart. Add the shipping details, payment details, and then place the order. Now that we have gone through the standard order process, let's have a little fun and manipulate the process to try and get some free products. First, we will clear out our cart. Next, we will add some exploits to our cart, and then begin the checkout process. What if we tried to skip a step, say the payment step, just by editing the URI path? Let's try it. We will replace step 3 with step 4 in an attempt to bypass the payment step, which seems to work. Now, let's see if we can place an order and get our products for free. Hey, yes, we can. And we see that we now have a new order, order number 10, that we didn't pay for. This is an example of an application logic error, and while some more advanced web application firewalls could possibly be configured to mitigate this, many could not resolve this issue. Logging out of the unshielded site and moving back over to the shielded site, we clear the cart and place another order. Again, we attempt to bypass the payment step, step 3, by modifying the URI path. But this time, we are taken back to the shopping cart. Now, no WAF can actually do that. A WAF may be able to block the functionality abuse, but at this stage, the user would have been given a blocking page instead of simply being forced back to the beginning of the checkout process. Our shield object in this case provides a superior user experience and protects the application from abuse at the same time. Now, let's complete the order on the shielded site using the standard order process, and we see that we have order number 11 added to our list of orders. Again, we will log out of the shielded site and move back over to the unshielded site to show the final piece of this demo. This time, instead of placing an order, we will view our previous orders. Note that order numbers 8 through 11 belong to our user, user 1. By clicking on the details link for one of our orders, we can see the details for that order. And notice that there's an ID parameter in the URI path that correlates to our order number. If we change that parameter value, a poorly coded application might allow us to view another user's orders. Let's try it. We will change the order ID parameter to equal 7, and we see that we can in fact see another user's orders, in this case, user 2. Now, let's log out of the unshielded site and log into the shielded site and attempt the same exploit. We log into the shielded site, click to view our orders, click the details of order number 8, and modify the parameter to order ID equals 7. This time, the user is sent to a blocking page, as this is clearly abuse by the user and would serve no function to be redirected. Like the previous example, this is a logic flaw, this time using parameter tampering. The application does not protect against this type of functionality abuse. Unlike the previous example, where an advanced WAF could be programmed to enforce a particular path to be accessed in a logical order such as URI path / step 2 must come through URI path step 1, and URI path / step 3 must come from URI path step 2, etc. This form of parameter tampering cannot be protected in the same way, and even an advanced WAF has no way to correlate a user to a particular parameter value, and thus it cannot provide this protection. A WAF can, of course, enforce parameter values and types, but we didn't do anything wrong with parameter values and types. A WAF cannot make the leap to understand the context for users and thus cannot resolve this flaw. Before RedShield's microservices shielding objects, the only way to mitigate this issue was with proper coding in the application. This is an incredibly powerful protection that can be deployed very quickly, giving an organization the time to properly remediate their application code while still protecting its users. Shield first, then remediate. Thank you for watching this demonstration presentation. For more information, please visit www.redshield.co or contact RedShield Sales at sales@redshield.co.